Hi, welcome to our next video on Level 2 networks. In this video, we're going to explore Euler paths and Euler circuits. Now we know a network is a diagram, which we often call graphs, that consist of edges and nodes or vertices. This topic can be called graphs, networks can be called graphs, and the area of mathematics is often called graph theory. Now a node is kind of like a point in a network, and an edge is a line that connects the nodes together. Also remember from our first video that the degree of each node is the number of edges which come out of or go into each node. Let's get into today's work. If it's possible to start at a node and move along each edge only once and traverse, which means to travel the entire network or the entire graph, then the graph is regarded as being an Euler path. Let's show you what I mean. Let's start at A and move to node B, and then move to node C, and across to node D. Now I haven't travelled the entire network. I've left off the edge between A to C, node A and C. I can't go back along an edge, I only can move along an edge once. So this is not an Euler path. But notice what I'm about to do now. I'm starting at D, moving across to node C, up to node B, across to node A, and down to node C. I have now travelled or traversed the entire network, the entire graph. So this is an Euler path, and we say the Euler path is from D to C to B to A and back to C again. I could do it a different way. What's this? From D to C, this time I'll go up to node A, then down to node B, and then back to node C. So I've once again traversed the entire network, the entire graph, and so therefore this is an Euler path, from D to C to A to B, back to C again. And this is a different Euler path than the example I just showed before. So you can have different Euler paths on the same network. Now, a lot of people like to use this as a common thing. If we can draw the graph without lifting our pen and without going over any edge, which means a line, more than once, we have an Euler path. And you might have played these games a little while ago when you had to draw shapes without lifting your pen off the page. All right, well, let's move on to this next bit. If the graph is an Euler path and we start and finish at the same node, then the graph is now regarded as being an Euler circuit. So let's do this again. Starting from node D, across to node C, up to node B, up to node A, and down to node C. But we've started at D and finished at C. So although this is an Euler path, it is not an Euler circuit. Let's show you a classic, something you may have done when you were young, trying to draw the shape without lifting your pen off the page. I'll show you how we do it. We start at, say, node A, move to node B, down to node C, up to node D, down to node E, and up back to node A again. And notice in this example, we've started with node A, and we've finished at node A. So this is an Euler circuit. So Euler circuit for this network is A, B, C, D, E, and A. Now actually it doesn't matter where you start on this circuit, this network, you would always end up at the same point. So there's lots of different Euler circuits for this network. Let's have a look at this one. We're going to start at node A and move to node E, go from E down to B, from node B to D, from node D across to C, from node C up to B again, and from node B back to A. So we started at node A and we finished at node A. So it is an Euler circuit from A, E, B, D, C, B, A. Notice in this example, we came across node B twice, and we're allowed to do that. We're only allowed to go along each edge once, but we can go into any nodes as many times as we need to. Right, that's us for this video. So thanks so much for tuning in.